Amazing people. Here's another problem where we need trigonometry to solve it. So from the top of a building, Tom measures the angle of elevation of the top of another building as 27 degrees. And he finds that the angle of depression of the base of that building is 39 degrees. The building he is observing is 30 meters away. How tall is it to the nearest meter? So the first thing we want to do here is we need to draw a diagram so that we can process this information and understand what we need to do. Okay, now with this diagram, we need to add the information onto it. So one of the pieces of information we're told is that the angle of elevation to the top of the other building is measured as 27 degrees. What that means is this angle here, this is going to be 27 degrees, which is being measured. Then we'll find that the angle of depression to the base of the other building is 39 degrees. So this is looking downwards now. So this is going to be the angle below that. That's going to be 39 degrees. And so from here, we're also told that the building he observed is 30 meters away. So we can record that here at the base, but then that also translates up to this dotted line, and we know the distance between those two buildings is 30 meters. So what we're being asked to find now is how tall is it to the nearest meter. So based on this, we're going to have two triangles we have to work with here, which make up this building. We've got one, which is going to look like this as a right angle triangle. We've got another, which is also a right angle triangle, which is going to be more like this. And so from this, if I transfer the information across, that's going to be 30 meters, that's going to be 30 meters. This angle here is 27 degrees, and this angle here is 39 degrees. And so what we need to do is we need to find two different lengths here. We need to find this lower length. We can call this one X. We need to find this upper length, which we can call Y. But then what we need to do to find the total height of the building, the total height of the building is going to be equal to X plus Y added together. And so that's the process we need to work through here. So as we go about that now, in the case of finding X, this one X here, we need to identify the sides we're using. So the sides we're using, we've got an adjacent and we've got an opposite. So that's going to be using the tan ratio. So from this, if we use the tan ratio, that's going to be tan 39. That's going to be O over A, so it's going to be X over 30. Rearranging this, we have X is equal to 30 times tan 39. Then to find Y in this instance, again, we've got 30 is also going to be an adjacent and Y is going to be an opposite. So we're using the same ratio of tan, and this is going to be tan 27, and this is going to be equal to Y over 30 as well. So rearranging this, we end up with Y is equal to 30 times tan 27. And so in this instance, when we work it out, we'll be able to find the value of that Y ratio. So using a calculator now, we're going to go 30 times tan 27. This gives us 15.28. 29 when we round that off. And I'm going to leave it in this format for now, even though I need it in the nearest meter, is I want to keep those decimal places for when I add it to the X value to ensure that I'm not missing a meter where it should be rounded. So the X value now is going to be tan 39. That gives me 24.29. Okay, now to find the total is going to be X plus Y added together. So that's going to be 24.29 plus 15.29. And you'll see why I've left these together. So 24.29 plus 15.29. When I add these together, we get 39.58. Now, when we round this to the nearest meter, we find that that's 40 meters, which is why I kept that extra information of the decimals to begin with, so that when I added these together, I didn't get a mistaken number of 39 when the actual answer was 40.